Hi everyone, welcome again to Coding Betonsi English version. So today we're going to discuss lowest common ancestor solution from SPOJ. To be able to understand the binary lifting that we're going to use to solve this problem, you should watch our first video, which is binary lifting explanation, kth ancestor of a tree node. It's a hard problem from LeetCode, and let's get started. So the idea, I will try to explain using an example. So let's draw a tree. This is my tree. Okay, so if we want to find, I will add some additional nodes. If I want to know the LCA of these two nodes, this one and this one, the result is this one. This is the LCA. Then another example. So LCA of this node and this node is this node. The easiest solution is to generate all LCAs for each node and then check them. For example, if this node is 7, 8, 7, 6, this one is 1, 2, 3, 4, 5, 6. So to get LCA of 6, 8, LCA of 6, 8, we need to generate all ancestors of 6. So ancestors of 6, they are 1, 2, 3, 4, 5, 6. And then all ancestors of 8. So it's 1, 6, 7, 8. And then we will find the last intersection of these two lists, and it's 1. So for this solution, the complexity will be too big, and we're gonna get time limit exceeded because we have queries, and each time we should do this process. So it's number of queries multiplied by the number of nodes, and the result will be too big. Okay, so how we can optimize this problem using the binary lifting technique? The first step, so our first step, let's draw again. Okay, so step one, we should move the deepest one to the level of the other node. Then their depth should be equal. So for example, this is depth 0, 1, 2, 3, 4, 5. As we can see, A has depth 5 and B has depth 3. We should move A to depth 3, so they are in the same level, same tree level. That's the first step. And doing this step, maybe we will find that A equal B. So imagine that this is B, so this is B, this is A. When we move A to the same level of B, maybe we're gonna have A equal B, so the LCA will be will be B. So if A equal B after doing the move, after moving A, then the LCA of AB is equal to B. Else, if we have this case, we're gonna do something interesting to know. So second step, we're gonna try something similar to binary search, but from top to bottom. Let's take an example. So we have many ancestors, many common ancestors. So this is a common ancestor, 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 and this is the LCA that we are looking for two nodes A and B. So this is B and this is A. As we discussed, first step, we move the node with the greatest depth to the second position. So step 1 up, we put them in the same level. Okay, then we're gonna try to move to the first node. Then if we move this, how to move it? It's up of A with something that we call E. It's equal to up of B with the same step as they are in the same level. So if they are equal, we don't do anything, because we know that this node can be two cases. Can be a simple common ancestor, or can be the lowest common ancestor, so we don't move. Then we divide by 2. So we we suppose that this one is 16 and this one is 8. So we try 8. We find that the result is equal, so it can be a normal common ancestor or maybe the LCA. We don't do anything. So then we move to 4. Okay. Then if they are not equal, that means that it's not neither LCA neither common ancestor, and we should move. In this step, when they are not equal, we move A and B there. A and B. So A will be up of A, E. E in this case it's 2, because 2 power 2 is 4. And B will move to up B, A. Now we started 16, 8, 4. Now we're gonna test 2, and we still have to test 1. So when we're gonna try 2, my drawing is not good, but imagine that this one is 8, this one is 16, this one is 4, and then I will do this one. We suppose that this one is 2. So same case. When we try up with 2 steps, we find that they are not equal. So we move A and B to this one, and then we still have 1 step to go to the LCA. So we are in the last one. Up of A 0, 0, because 2 power 0 is 1. We're gonna find that it's equal, and here we find the LCA. So we don't move, but the final result will be up of A, E, up of A 0, which is its direct parent. Okay, so that's the idea, and now I will explain how it should work. Okay, let's imagine that when we check up A and B of 4, which is 16, they are equal. But in the same case, it's the ancestor. So this is number 16, and then it's the LCA. Okay, so then we're gonna try 3, 2, 1, and 0. They are 8, 4, 2, and 1. So as 16 is the LCA, I know that for each node from 15 to A and B, the result will be different. So up, I know that I will be different, and each time I will move. So the first one I will move by 8, then I will move by 4, then I will move by 2, then finally I will move by 1, and the sum of 8 plus 4 plus 2 plus 1 is 16. And how I will get back to 15, sorry, and how I will get back to 16? It's simple, because finally I said that we need to do up of a 0. I hope my explanation was clear. So let's move to the code. I will share with you my GitHub link. So the DFS is similar to the one we used in binary lifting video. I will not explain it again. Kth ancestor is the same, so I will not explain it again. And here I will explain this part, the part of finding the query. Okay, let's focus here. So at the beginning I will read A and B, so to find which one, not which one, but to read the A and B to find their LCA. So I will suppose that A has usually the greater depth. So if the depth of A is not greater, I will swap A and B. Then I will get the difference. So the difference is depth A minus depth B. And I will move A by the difference between them. If A and B are equal, so I will just say that the LCA of A and B is A or B because they are equal. Else, I will try to move them. So when I have 16 nodes, I have that I know that the max move that I can do it's 16, or even lower, because for example, if you have 16 nodes, we have 7 from this part and 8 from this part, and this is the number 16. So worst case is that A and B are leaves. So this is A and B, they are leaves, and I need to move this one by 8 and this one by 7, or both by 7. So my worst case is logarithmic base 2 of number of nodes. So if it's 16, I know that I'm gonna move 16 steps, which is 4, because up of my node E is just the moves when E is 2 power E, so A, not power E or G. So that's it. So I will try to move starting from L, which is logarithmic, to 0. So I get the result CA and CB. If they are not equal, I will move, else I will not move, and finally I will output up of a 0. I hope you enjoyed the video. Thank you for watching, and let's discuss in the next video the problem from code forces that will use these 2 techniques. See you again.